Hello and welcome. My name is Maciej Soja, and in this video I will talk about airborne measurements of forests. Remote sensing is about measuring and mapping in remote, inaccessible places. The easiest way to get near these places is from air. The first attempts of airborne remote sensing were made in the mid-19th century. This is a photograph of Boston, made from a balloon from a height of 630 meters in 1860. Later, cameras were mounted on kites and pigeons. In 1909, a camera was taken aboard the first aircraft, the Orville Brothers flying machine. Nowadays, camera-equipped drones are used for many applications, from highly specialized military surveillance to hobby-level drones that can be used for spying on neighbors or celebrities. Today, we also have access to other sensors utilizing techniques such as laser scanning and radar, which significantly extend the usefulness of airborne remote sensing. Airborne or aerial photography is based on a very simple principle. An optical camera is mounted on a flying platform, a balloon, a blimp, an airplane, or a helicopter, and photographs of the ground are required. Aerial photography has many advantages. Modern cameras are cheap and easily accessible. Optical imagery is usually easy to interpret and provides useful information on land use. For example, no special training is needed to interpret this image. In the upper left corner we can see a forest. A farm can be seen in the middle and two brownish dikes can be seen to the right. Aerial photography can be used to map and monitor damage caused by forest fires, as well as storms. However, one of the largest shortcomings of aerial photography is its sensitivity to cloud and solar illumination. Moreover, optical waves do not penetrate tree canopies, and the sensitivity to forest biomass is low. An extension of aerial photography is stereophotogrammetry. With this technique, two or more images are acquired from different angles. Using the same principles as our eyes use to determine distance, elevation can be measured by comparing the length of the shadows seen from different angles. This is the technique that is commonly used to determine the elevation of mountain tops. In this example, a hexacopter equipped with a camera is used. It is flown over a building along the blue track, and a large number of images are required. Using stereophotogrammetric processing, a three-dimensional model of the scene can be created. Stereophotogrammetry inherits the pros and cons of aerial photography. The technique provides useful information and it is relatively simple to use. However, it requires identification of common points in two images, which can be time-consuming and problematic. In recent years, airborne laser scanning has become the main technique used for forest mapping. Airborne laser scanning, or ALS, uses a laser sensor mounted on a flying platform which scans the ground at high vertical and spatial resolutions. Typically, visible or infrared light is used. The resolution and coverage both depend on the altitude and the properties of the system. High-resolution airborne laser scanners, also called small footprint laser scanners, usually fly at altitudes of a few hundred meters and point densities often exceed 100 points per square meter. Here you can see an aerial photograph. A house, a field, a forest, and a power line can be seen in the image. And here, an ALS height image is shown. It is very easy to measure the height of the forest and to get some feeling about forest density. Due to its high vertical and horizontal resolution, small footprint laser scanning gives information about the vertical structure of the forest, which is good for biomass estimation. To summarize, airborne laser scanning is a very useful technique. It carries information about vertical structure and very high spatial resolution can be obtained. However, it inherits the same shortcomings as the other techniques using visible or infrared light. It is sensitive to clouds. Nevertheless, ALS is often used for local inventories. The airborne measurement techniques discussed in this video, aerial photography, stereophotogrammetry, and airborne laser scanning, All provide useful information and are commonly used for local inventories. However, due to the limited coverage and the requirement of good flying weather, airborne techniques are inefficient on a large scale and whenever frequent acquisitions are needed. Moreover, techniques using visible or infrared radiation are sensitive to clouds. As we will see in the next two videos, these problems can be overcome with satellite-mounted radar systems. Thank you and see you again soon.